All right, class, welcome to lesson 13. This is an activity and a lesson that's going to involve the area of squares and rectangles. Okay, we should remember how to find the area. Okay, so for this activity, you're going to be spending some time with graph paper, and of course, we'll be going over this in class. You're going to be making the drawings here. You can see the directions that they ask you to follow here. I'm going to go over this with you to see, make sure you have been able to answer the questions correctly. So for question number 1A, it says how many squares with side length of 1/4 inch can fit in a square with side length of 1 inch? Well, so if we picture the side length is 1 inch, how many 1/4 inch segments are in 1 inch? Well, there's 4. 4/4 would be 1 inch in this case. So there's 4 of these little 1/4 inch squares that will fit into a side. But if it's a square, that's 4 sides. So you're talking about 4 squares per side times 4 sides is going to be 16. Okay, so it would be 16 squares with that length that would fit in an entire square if that's what one side is. Okay, so and then for the area, what is the area of a square with side length of 1/4 inch? Well, think back to how we find area. We find area by finding length times width, right? Or base times height, or B times H, right? So in the case of a square, you're just talking about one side times another side, and the sides are the same length, right? So if the sides are 1/4 inch, then what you're going to be doing is you're going to be taking 1/4 and you're going to be multiplying it times 1/4. Every side is the same, it's a square. So 1/4 times 1/4, that is going to equal 1/16. Okay, so that's the area. It's 1/16. 1/4 times 1/4. All right, next one says to use a ruler to draw a rectangle that is 3.5 inches by 2 1/4 inches on graph paper, and write a division expression for each question and answer the question. Okay, so if you've done the drawing correctly, you're going to be able to figure out how many segments there are in this here. Okay, but we want to be able to write the division expression. Okay, so it helps. We just need to understand what's happening here. How many 1/4 inch segments are in a length of 3.5 inches? Well, so what's happening is you're taking the length, the 3.5 inches, and you are splitting it up into segments that are 1/4 inch long. So if we split those up into segments, that means we are dividing them. So 3.5, sorry, divided by 1/4. Okay, so the answer to the question would lie in solving this here. So let me show you how to solve it. Okay, or remind you of how to solve it because we've covered how to do these before, right? 3.5, that's 3 times 2 is 6, plus 1 is 7. 7 halves. And when we divide by a fraction, we can change it to multiplication. Flip this upside down. We get the reciprocal. It's 4/1. All right. And then I can see here through cross canceling, this is 4/2. Okay, which really means that this is 2 and 1 here. So 7 times 2, that equals 14, right? And then 1 times 1 is 1. I don't need to put 14/1 because 14 tells us how many segments there are. All right, so let's take a look at the next one. If we look at letter B, it says how many 1/4 inch segments are in a length of 2 1/4 inches? Well, so once again, what you're talking about is the length of 2 1/4 inches being split up into segments. So we're going to take 2 1/4 and we're going to divide that by 1/4 because that's how big the segments are that we're working with, right? So 2 1/4, let's make that into a fraction. So 2 times 4 is 8, plus 1 is 9. So 9/4, or 9/4. Instead of divided by 1/4, it's the same thing as multiplying times 4/1. And look here, this is going to cancel very easily, right? This is like 4/4. So that means it's really going to be 1 and 1. And 9 times 1 is 9. 1 times 1 is 1, and we don't need to put it over 1, so I'm actually going to go ahead and erase that. It's 9. All right, that's what we are talking about. 9 segments that are in this situation here. Okay, and then for the next one, you should have your drawings out and able to look at them and see them here. So I'm going to have you guys make sure to take a picture of them and add them down here. Okay, I'm going to add a little notation in a second telling you to put your pictures there of your drawings. Let me go ahead and show you how to prove what they're showing here. They say use your drawings to show that a rectangle that is 3.5 inches by 2.25 inches, that's the one that you've already drawn, that's this one here, has an area of 7 7/8 square inches. Okay, so we could, of course, do the math here. We could do 3.5 times 2.25, since it's going to be base times height or length times width. So if you do 3.5 times 2.25, you'll get 7 7/8. But we want to be able to show it with our drawings. So I want you to see how this can look. There's a couple different ways to do it, and instead of me taking all the time to do it, I want to show you what they can look like. So here we go. Okay, so one of the ways you can do here, you can fill the rectangle with squares with side lengths of 1 inch and side lengths of 1/4 inch, and adding in their area. So you can see here, this is 1, 2, 3, 4, 5, 6. So this is 6 square inches right here. These two are a half each, so these two together become the 7th. All right, and then down here we have a quarter and a quarter and a quarter. That's 3/4, and 3/4 is the same thing as 6/8. And then if we add in this last 1/8, that's where the 7/8 comes from. So this is one way to show 7 7/8. Okay, and then another way that they can do it here, you can see here we can break it down into parts. And if you break it down into parts here, you can see on the drawing they have a 3x2 rectangle. So that would be the 6 square inches, right, just as I head up here. And then a half inch here, 1/4 inch here. So it's basically it's very similar to what they have up here. They're showing it in a little bit of a different way. So those are the two ways that could have worked. All right, make sure there's nothing else to cover here. Nope. On to the next activity. See you soon.